that I worked on, just a hypothesis that I had. And I'm sorry to say, we don't find any exciting results. This is about the process of thinking about our data and analyzing our data. Yeah, and maybe there's a little bit of a signal that will turn out to be valid, but we just don't have a strong conclusion yet. So what's the concept? So anchoring versus adjustment. I mean, I don't like to use the word anchoring because it generally refers to anchoring to your prior belief. It's like a resistance to updating your opinion in the face of evidence, whether that be concrete evidence or other people's opinions. And I like to say there's a bit of a personality spectrum, right? Some people will be very deferential, very humble. They will automatically give up their belief for the community's belief. And there are people on the opposite side who will stick to their guns. And potentially even more, maybe some people are being activists, and they would, when they see the community prediction is higher than their own, they'll go in the opposite direction just to try to push it back. And there's this general idea of Allman's agreement theorem, which roughly speaking is like, if you and somebody else have the same prior about something, and you have just as much access to information as the other person, and you're both honest to each other, then it should be impossible to disagree. It should be like, well, given what you're telling me and given what I'm telling you, we should basically converge to the same opinion. Right? And so the question is like, well, how much is that actually happening on Metaculus? So what is Metaculus? I guess everybody already knows this, right? And what is the community prediction? Well, the community prediction is a kind of recency weighted median of people's opinions. So like the latest opinion has a higher weight than an older opinion. And there's also something called the Metaculus prediction, which is our best aggregation method. But we generally don't publish that. And in this presentation, I'm focusing on the community prediction. So a priori, before we even look at data, we should think about how would we even define adjustment. And by the way, do you guys still hear me? Anastasia?
Yes, I can still hear you.
Okay, great. So basically, there's an initial period in most questions in which the community prediction is not visible. This is also true in tournament questions, but these are two different situations that are, possibly both interesting, but we did not distinguish them in our data set. So because there is this moment in which the community prediction is suddenly revealed, this is like a natural experiment. It's like we can treat whatever systematic updates that happen at that time as causal, right? So it's an assumption that you make that that effect is a causal one. And so the way we thought about this is for a given user in question, right? There's a series of forecasts by that user on that question. We define this model where the prediction after the reveal is equal to the prediction before plus some lambda, which we call the adjustment coefficient, right? Or maybe the humility coefficient, times the difference between the community prediction and the prediction before, right? So the presumption here is that lambda will be between 0 and 1. Let me actually go to the following slide, right? Because if lambda is equal to 0 given this formula, that means that the prediction after is just equal to the prediction before, right? There in the stubborn category. And if lambda is equal to 1, then they're completely changing over to the community prediction. This is total humility. But to be a little more precise, this is not total humility, because the community prediction incorporates their prior opinion. So if they were completely humble, they would in fact have lambda slightly higher than 1. And I would expect that, good forecasters will have lambda between 0 and 1. That's my hypothesis. But you could also have people, and on any given instance, people may have information of different kinds, and they may go above or below this range. So we really should consider the average, right? A user's average over many questions, right? So what we looked at is data in which users who had more than at least 50 resolved questions by the end of our training period. And by the way, this is relatively old data. This is 8 months ago. And we were considering 164,000 predictions on 1,028 questions, which results in 54,000 question user pairs. And then we also considered the predictions of the top 10 users, right? So we're basically comparing top 10 versus everybody else. And we define top user according to relative Brier score, which is very different from being the top of the ranking. And maybe I shouldn't say very different, but it is different. And here's a now a sequence of results that don't necessarily show very much. So we define the deltas. So the deltas are the differences in a user's forecast between the current forecast and previous forecast. And we would expect that the delta that crosses a revelation, the community prediction revelation, would be presumably bigger than the other deltas most of the time, right? And so we would hope that to be a pretty high quantile. So in the distribution of all the deltas, we would expect this to be probably, I don't know, more than 90%, higher than 90% of them. And we don't, it really doesn't seem concentrated around, it looks like it just goes everywhere. This very much looks like a null hypothesis, which is suggesting that maybe people are not really looking at the community prediction, or maybe they're looking but they don't care. And then I did a few more analyses. What is the distribution of this lambda, right? And this is, you could interpret this as being shocking, because about a quarter of the time, well, let's just say 20% of the time, it's greater than 1, and about 25, 30% of the time, it's less than 0, right? So being less than 0 means that people are digging their heels in even more, and greater than 1 means they're being exceedingly humble. And then the question becomes, are the top 10 forecasters different than everybody else, right? And then top 10 forecasters are in red, and it's really not that different. When you do a statistical analysis, two-sample test, you get not quite a significant p-value. And then interestingly, if you do this at the level of the median, so we're like, okay, now we're going to just consider the median for each user over many questions. What we discover is that it does seem a little bit tighter, like maybe they are more reasonable than the others, because it seems, at least visually, to be close, to be within the range a bit more often, but this is not statistically significant. And it could just be that I need a bigger sample size. And ideally, we should also distinguish between tournament questions and regular questions. And then, so I did this for using log odds, and then using just probabilities, and it just doesn't really matter. So so there's I would say the number one thing for future work is use more data, even more recent data, and yeah, maybe also another aspect is taking time into account. Sometimes a large time gap between successive forecasts might explain the large gap, but this feels like I'm overthinking something because we don't have a clear signal yet. So that's all.
Cool. So Gustavo you have some time for Q&A, right?
I guess I do.
Yeah. So feel free to raise your hand or drop your questions in the chat. We have a question from Nikos.
Okay.
Let's hear it.
Yes. Hi, Gustavo. Thanks a lot for the talk. My question is, do you sort of have plans or ideas whether basically in the instances where people did update or did not update, they did that correctly or incorrectly? Because you're looking at the distribution of updates, but I think it would be like every point that is an update also has information about sort of whether that was the right call or the wrong call. So I think it would be interesting, like it might be the case that sort of good forecasters don't update exactly as much as bad forecasters, but they do it in the right instances. Do you have a sense of that? Otherwise, that would be a suggestion for
I like it.
Things to look into.
Thank you for this suggestion. I don't have. Yeah, I was really not focused on that, but it seems like a very important thing. Yeah, thank you.
Does anyone else have any questions for Gustavo? Gustavo, I actually have a question, which is, was the hidden time period consistent across the questions you evaluated, or is there an impact of like how long the question or the CP is hidden? Is that something that you looked at or have a hypothesis about?
I did not look at that, and my understanding is that this is different between tournament questions and regular questions. But again, there's just not enough data to get much of a signal.
Yeah.
Which probably means I've been filtering too aggressively, or I've not been using recent data, or both.
Does anyone else have any questions for Gustavo before we? Oh, we do. We have a question from Till, which is, what are the? Oh, Till, yeah, go ahead.
Yeah, thanks for the talk. My question would be, how do you determine the 10% top forecasters? Is this by absolute points or is it by average points?
A relative Breyer score. So the Breyer score is not something that is, I would say the most visible thing on the website is probably the points. And the rankings are probably on the points, right? Please correct me if I'm wrong. But Breyer score is a proper scoring rule. Yeah, I mean, I believe and I think many of us believe that is a superior way to score people. Not necessarily the very best way, but maybe better than points.
Just to say as well, relative here means relative to the community. So
right.
It's like the difference between the Breyer score that the community prediction gets and that the user gets on all questions that the user has forecasted on.
Oh yeah, and I forgot to mention this other potential issue, which is that if someone fails to predict, could it mean that they still believe their opinion is the same, or does it mean that they're just not paying attention, right? And that feels ambiguous. It's irrelevant.
Any other questions for Gustavo? Yeah, I'm going to apologize if I've mispronounced your name, but Srinivasan?
Yeah, and I also apologize since I'm driving, but I just wanted to ask this question. So, did you notice that? I mean, first of all, a clarifying question: when you look at the differences between A minus B and everything, are you looking at medians or is this distributional difference?
I looked at both means and medians, and the unaggregated differences. So one of the slides shows unaggregated, and the other slide shows aggregated by the median.
No. What I meant was like if because the forecasts are probabilistic forecasts, are you looking at the difference between the distributions
Oh,
themselves?
these are not. These are for binary questions only.
Oh, binary questions. Okay, thank you.
Yes.
And the other thing we noticed, at least during some of the RPDM tournaments that we were running, this was not focused on the hidden period, but during the duration of the question, we saw that related to what Nikos was mentioning, not just the timing of updates, but the amplitude of updates changed as the question was kind of coming to close. Some users were making more micro updates of the shape of the distribution rather than actually adjusting the median because they were maybe optimizing for their score or they had better understanding of the shape of the uncertainty. Whereas early on, it's more of like a large scale movement. So I don't know if there is something there in just understanding when is that happening, irrespective of whether they're seeing the community or not.
Yeah.
There is some information there, I guess.
Yeah, so this is related to Anastasia's question, actually. Right, so in this data set, there's very few tournament questions, or at least the ones that passed my filters. And as a result, almost all of them are having the community prediction reveal in the beginning after approximately 10 predictions. Right, I shouldn't state that so casually. I should probably look at that before I said this, but it's almost all of them in the beginning of the question. So it would definitely be interesting to look at tournament questions because those tend to be later in the period.
Yeah, and also just to clarify, like I meant not just during or like before and after the hidden period, because sometimes it's very difficult to find like a forecast that was done just before and just after, like that talks to the time duration between forecasts. So what we were tracking was more of look at all the forecasts that they made during that like 3 week that the question was open, and try to see the update amplitude based on when they are like, I mean, if they're getting closer, and since these are, they're also tracking some kind of an environmental variable as they get closer to forecast, they have smaller changes.
I can imagine a fun project if anyone is still, in case anyone is still considering other projects, something in which you're modeling the variance of these updates as a function of time, and potentially you could add the reveal as a as a spike, as a feature in that time series, in that function, right? Presumably it's getting smaller, the updates are getting smaller as time passes, but it might be temporarily bigger when the reveal happens, right? So.
Yeah, so almost like a phase transition during that time.
Yeah.
Okay.
Sounds like an interesting model.
Okay. We'll start forecasting the forecasts at that point, I guess.
Yeah.
Thanks for the great questions. I actually, Eunice, I apologize. I think in the interest of time, we're actually going to move on to our next presentation. If we have time at the end, once Peter is done, we can circle back to Gustavo as well. But with that, Gustavo, if you want to hand screen sharing over to Peter. Up next, thanks, Eunice. Up next, we have Peter, also from the Metaculus team, sharing one of his explorations into our data set. So, Peter, I'll let you share your screen.
Yeah, thanks for having me. Yeah, let me think. Okay, hopefully this works. Oh. Okay, let me just try to figure out the screen, sharing the screen. Right. Okay, I'm sorry. Okay, let me just shared hidden. Okay, sorry. I hope to would be able to share it with my iPad, but it was not meant to be. Okay. Right. So today I want to talk about martingales in forecasting, or for those who are not familiar with martingales yet, can forecasts be kind of objectively wrong? And the outline of the talk is roughly, so first I want to start by kind of elaborating on what I actually mean by objectively wrong. Then I'd like to kind of outline how or why forecasts are supposed to be martingales. So if you don't know what a martingale is, don't worry. I'll also define that. And then I want to kind of dive into some implications of that. In particular, explain what martingale tests are, and if I have time, maybe even link it to some psychological biases, which might even be a little bit related to what Gustavo was talking about. Okay, so without much further ado, right, so let me just start by breaking down what I actually mean by all these terms here. So by forecasts in this particular setting, I actually mean the evolution of forecasts of a binary question. So for the example, this PT here, this green curve, could be the probability that Biden gets reelected, given the information it's available at time t. So this is a probability that should evolve in time as you learn more about the state of the world. And I want to abbreviate this just by FT here and on future slides, just to save myself the hassle of writing information available at time t every time. Okay, so what do I mean by wrong? So you can't really say that a forecast is objectively wrong, but you can say something like, well, if the forecast is like a proper Bayesian with like not completely insane price, then a forecast like this shouldn't happen a lot. So for example, so this epsilon here should be thought of as small, and you could, for example, see that this is possible by taking A here to be the set of forecasts that at some point reach 99%, but then resolve negatively, so they go down all the way to 0. So clearly, if you're like proper Bayesian and a good forecaster, then this can't happen like more than in 1% of all your forecasts. So this epsilon here would be 0.01. And what do I mean by this objectively? So by this, I actually just mean that for this talk, like no model assumptions are made. So this holds, like whatever I say in the future, should, like definitely holds. Like no caveats, no model assumptions. Okay, so let's get to it. So what can we say about this evolution of forecasts, this process PT? So PT is kind of like here now today's forecast. So that is the probability of some event X given the information available at time t. And just by the definition of a conditional probability, really, there's nothing particularly deep about this. We can write it with this equation here. So that's the sum over forecasts of estimates of the probability of X given some state of the world Y times the probability of the world being in that state tomorrow. And kind of by definition, we can actually combine the sum and end up with this expectation here. So if I just put it together, then I obtain this formula here that's highlighted in green. And I see that today's forecast, as I said in this, like up here, is just the expectation of tomorrow's forecast, conditional on what I know today. Okay, and that is it. That is like, okay, up to technical details that are satisfied here. This is the definition of a martingale. Now, this is not particularly deep yet, but the point is that we do know and do have a lot of rigorous results for martingales. So for those that have some experience in that, just try using the optional stopping theorem or Dupes inequality or even Ito calculus to say something about this evolution of forecasts, and you will find that every theorem about martingales actually gives you something interesting. So let's see what these probability valued martingales look like. So one example is kind of one extreme case, if you want, is this case where there's just a few major updates. And in this case, we'll end up having like a pretty flat process. It's basically constant with a few jumps. So you see it at the very end of this graph here. I think it is when rumors of Musk taking over Twitter emerged, then the probability of Trump getting back on Twitter kind of increased quite significantly all of a sudden. Now, another example would be a lot of minor updates. In that case, this martingale kind of looks like this. So this is 538's forecast for the, I think, the presidential election of Clinton versus Trump. And you can see that it's actually like really volatile. Kind of looks a bit like Brownian motion. Brownian motion is also martingale. But yeah, it's obviously not, because this one is banded between 0 and 1. And you can actually see that it kind of starts at around 50%, then it goes down all the way to like almost, I don't know, 15, then it goes up all the way to over 90, goes down to 20, goes up to 80, and eventually resolves negatively. So a lot of people actually criticized 538 for being too volatile, and this can't possibly be Bayesian updating, because essentially they're overreacting. And well, with martingale tests, we can actually run the numbers and get concrete values for what it means to be for something to be too volatile. So the takeaway is actually that no, it's not too volatile, at least not volatile enough to reject the null hypothesis that this is actually a martingale, and hence Bayesian forecasting. And now a third example scenario that also got a lot of public attention semi-recently is this kind of question: will some event happen before some given time? And it also doesn't look like today's forecast is the expectation of tomorrow's, because it seems to just decrease monotonically. And I think Scott from Slate Star Codex, or ACX, actually well, conjectured that this Metaculus forecast here has to be wrong, because it's just monotonically decreasing, and this can't possibly be reasonable, but it actually can. And this is also just look at some kind of martingale, see what's possible. And yeah. So, right. So back to trying to make things a little bit more quantitative. So what does being martingale actually imply? So if PT is a martingale, then, for example, we know the first implication is that the autocorrelation of increments vanishes in expectation. So if you have lots of questions, or one questions with lots of forecasts, you should be able to verify that. But presumably it will only hold if you kind of average over like a couple of questions. And another implication, kind of independent of the autocorrelation one, is the one that I find particularly interesting for analyzing Metaculus data. So this says the expectation of this quantity here. So that's called the quadratic variation, and in some sense it's a measure of how wiggly your graph is. So this 538 forecast will have pretty high quadratic variation, whereas this forecast here will not have very high quadratic variation. You see, this is not very wiggly. This is very wiggly. And this has to equal, again, in expectation, the uncertainty reduction. So the reason it's called uncertainty reduction is if the question resolved, then either PT or 1 minus PT has to be 0. So this term falls away, and this ends up being just the initial prediction times 1 minus the initial prediction, and this is kind of maximal if we started at 50% and kind of get smaller if we were already close to 0 or 1 before. And we can actually see that averaging over lots of questions, this equality is approximately true for the Metaculus prediction, while the community prediction turns out to be a bit too wiggly. So that means that the left-hand side here is bigger than the right-hand side. So this kind of should tell us that the community prediction kind of updates a little bit too much, like it overreacts to news, so to say. And actually, there are like infinitely many more tests that you can derive via Ito calculus. So for those of you know who it is, just take this equation here and plug in various x's, and you'll get tests like this. So I think you get this test here by plugging in xt being 1 minus 2 pt, for example, and then doing some maths. Okay, and I think I'm running out of time. Apologies if I'm over time already.
Nope,
so I just want to
just go ahead and finish this.
Yeah, so I just want to leave you with this. So this is something that is written in greater length in this paper by Augenblick and Rabin. And so this kind of classifies a bunch of psychological biases by how much your quadratic variation or uncertainty reduction deviates from kind of a perfect forecaster's quadratic variation or uncertainty reduction, respectively. So if you had access to some perfect forecaster, then you could kind of classify these things. And like one project I'm somewhat excited about is, for example, to use the Metaculus prediction as a proxy for this oracle, and then define features for users and classify them as people who tend to overreact, have some confirmation bias, suffer from base rate neglect, or tend to underreact. And yeah, I think this is well stopped. So thanks for your attention.
Thank you so much, Peter. I saw one chat question, but does anyone have any questions before I just raise your hand? And otherwise, I'll turn it over to Nikos again. Right. Here he is, Nikos. Let's hear it.
Hi, Peter. Thanks a lot. This was really interesting. My question is, so on slide 14, I think it was, you looked at P0, and the thing that I'm wondering is, isn't it like kind of arbitrary what you define as P0, in the sense that sort of, if you showed like the 538 chart where you update to information, and like it was very wiggly, and at times you had very high probability and very low probability. But when you like by chance start predicting at a time when the probabilities of seems very high or seems very low, then you get a very different P0. Whereas if you set like the P0 as, I don't know, like starting to predict in, I don't know, like at the time of Biden's birth, you just like get a very, very different P0. And I'm wondering like how, like how much does that influence your estimate?
I mean, it influences it in the same way we award Metaculus point. Like you have to make your first prediction at some point in time, right? And like I guess like probably more in the spirit of what he had in mind. Well, what if we started forecasting at Biden's birth? I would say if you've started forecasting at Biden's birth, then you should also take the, it just has to equal in expectation. So if you start forecasting at Biden's birth, then you should also take the forecasts for forecasting for all other people, or like, for all other kind of, relevant people. Like you should probably keep track of like a whole set of predictions and average over them. like otherwise it's it's kind of like this kind of selection bias of you just happen to, like, in hindsight, choose the one forecast that wiggled a lot, because now we know that Biden actually even like participated in the tried to be elected. Yeah, so I think like no, we shouldn't start forecasting Biden's path, because that's hindsight bias in terms of evaluation of forecasts, at least.
But you wouldn't, sorry for the follow-up, you wouldn't in practice be worried about like any kind of selection bias by just choosing questions that you have. So it's like in practice, everything should be fine and should work out.
I would think so, but I'm open to the idea that some bias sneaks in somewhere. So if you have an idea, please do let me know. I'm not saying this is bulletproof against all sorts of bias.
Cool. Thank you, Nikos and Peter. I'm going to turn it over to Sylvain for the next question.
Yeah, thanks. Actually, it's very related. Wait a minute.
I'm sorry, I can't hear you.
Yeah, they're, I think, unmuting their big screen or muting their big screen. We have the full Metaculus team logging on from one room, watching you on the TV, your TV debut.
Yeah,
Levels of fame I never thought I'd read.
Can you hear me now?
Yeah.
Yeah, nice. So it's related to Nico's question, actually. How did you choose P0 for the Metaculus prediction and for the community prediction? Did you just take the first prediction in the time series, or did you wait for it to stabilize it?
I actually used, I think, Charles' work, who said that essentially the accuracy of I think the community prediction kind of stabilizes once 15 different people or so forecasted. So I took that as a cutoff, because otherwise you will always have excess variation, and like community prediction fluctuates like crazy in the beginning.
Thanks. Anyone else? Questions for Peter about this talk? Cool. Well, we are in our final 2 minutes, so I think we're going to wrap up here. Thank you, Peter and Gustavo, for sharing your work. For those of you who don't know, we're in the midst of a hackathon, and many of our hackathon participants are on this call or will watch the recording at a more convenient time, doing similar analyses, looking at the Metaculus data set and trying to come to new understandings from their work. So very timely to hear both of these talks. For everyone else, tomorrow's talk is with Dr. Michael Gilead of Tel Aviv University, looking at the psychology of forecasting. So we hope to see some of you there. Have a great day, everyone. Goodbye.